Welcome back, boys, to our final lesson of Chapter 7. It has been a very long chapter, and we are finally going to be concluding it this week. So this last chapter is solving simple radical equations. So you are all familiar with how to solve for x equals, so that should be nothing new. But the thing is that you will have radicals inside of these equations, and the point of the lesson will be to get rid of them in order to get x by itself. So I do have a few properties I want to show you. But before that, one vocab word will be a blank blank is an equation that contains a radical expression with a variable in the radicand. So if you look at this problem right here, if you notice, it looks a little bit different than usual. You do have an equal sign, you do have an x, and you do have some numbers, but there is a radical. So you would have to solve this by removing the radical and getting x by itself. So what you would call this is a radical equation. And of course, I just went over these steps right here. So you would use the properties of equality to isolate the radical on one side, which in this problem is already isolated. And then there's another property I'm going to show you that you would use to eliminate the radical, and then of course get your x equals. So as you know, every single answer you're going to get will be an x equals. And here is that one property I talked about. If you have two expressions that are equal, then the squares are also equal. So if you have a equals b, if you were to square both sides, you would get an equivalent expression. So if you do something to one side, you of course do it to the other side. And that should not be something new. It's just now you're going to be squaring each side in order to get rid of the radical. So if you look at this example, you have the square root of x equals 8. So the point is to get x equals. Now you have no other extra numbers near the radical of x. So the only thing to do is you need to get rid of the radical symbol. So if you square one side, you're going to square the other side. And if you square a radical, you are eliminating the radical. So all you have left is simply an x equals, and 8 squared is simply 64. And this was very easy. Now to check yourself, these are also easy to check. If you were to plug in radical of 64, it better equal 8. And you have. Now this one, in letter B, you have a 3 underneath the radical, but you also have an x. So the 3x acts as one quantity. So you do have no extra numbers around the radical, so you need to square both sides. You're going to get 81 on one side, and by squaring, you're eliminating the radical, and all you have is 3x. This becomes a normal equation. Divide by 3, and I do believe x equals 27. And if you remember, this is going back, I think, one chapter ago, the exponent of your x equals how many answers that you should have. So if you look at this, this is just an x to the first, meaning you will only get one answer. But if it was an x squared, you would get 2 answers, but that's not going to be the case in these problems, but that should just be something that you should have remembered. Now looking at C and D, if you notice, you do have some extra numbers. You have this 5 in letter C, and then you have this 10 in letter D. So the first thing we need to do is move the 5. So obviously you guys should know how to do this. Subtract your 5, and they go away. Again, no need to show that work. You have the square root of x equals 8. And now we have a problem that we just did, which is a very similar answer, is square both sides. You'll get 64 The radical and the little 2 go away because they are undoing each other. And all you have is x equals 64. Now, looking at letter D, you have this positive 10 over here. Don't get confused because this negative belongs to the negative radical x. So we're going to subtract negative 10. You still have a negative radical x equals a negative 15. Now, you still have this negative radical x. Technically, it's a negative 1 being multiplied. So we need to divide by this negative 1, which leaves us with radical x equals positive 15. We're still not done, but we have removed all of our extra numbers. But now we need to get rid of the radical by squaring both sides. And you guys should know that 15 squared is 225. Okay, a few more of getting rid of extra numbers. So if you look at letter E, you have 7 plus radical x equals 3. So obviously we have to move this 7. And you have radical x equals negative 4. Now we are going to square both sides, obviously, because that's how we get rid of the radical. And obviously this goes away. Now, if you remember, a negative 4 times a negative 4 does equal a positive 16. Now, here's the thing, though. We need to verify that this actually is correct. So if you remember, the radical of 16 technically does have two answers. It has a positive 4, right, because 4 times 4 is 16, but the radical of 16 also has a negative 4 because of this reason of having a negative 4 times a negative 4. So just FYI, that a square root does technically have a positive and a negative answer. So let's go ahead and look at letter F. Now, what's important is maybe putting some parentheses around the 5x plus 1. That is all underneath the radical. So the only number you need to move is this 2 because that's outside of the radical. So if I do that, this is what I have. And also being very neat with these problems is helpful. And 6 minus 2 is what? 4. Now, this is all underneath the radical. So we need to square the entire thing, which is going to give us a 16 on the right side. And this radical and the little 2 go away to become just a 5x plus 1. So nothing underneath the radical ever changes. So that is not a trick question. It's never going to change. And now this becomes a basic equation. Subtract your 1. And obviously you should know to divide by 5. And it looks like x equals 3. Whoops. Well, looks like my numbering's a little off. Don't worry about that. So if we do G and H, we have to subtract this 5 because it is outside excuse me, of the radical. And you're getting x minus 3 underneath equals 4. Obviously, you need to get rid of the radical. So we're squaring, getting 16. This is not changing. And obviously, if we add 3 to both sides, you are getting x equals 19. Letter H is extremely easy. Obviously, we need to move this extra number of 4. Whoops. Pen going crazy. And you're going to get radical of x equals 1. If you square this, the radical then disappears. 1 squared is not 2. It is just a 1. So all of these should have been extremely easy. You were just subtracting or adding extra numbers. Now in these next examples, you might have to divide by some extra numbers as well as then subtract or add extra numbers. So if you look at letter A, there is a dot right here of between that 5 times the radical of 2x. So the extra number there is the 5. And we need to divide by it because it is being multiplied. So you will have a radical of 2x equals 4, just like before. Square both sides. Radical disappears. You have 2x equals 4 squared is what, 16? Divide by 2 looks like x equals 8. Now letter B, you have two extra numbers. You have this positive 3 and you have this division of 4. We are going to subtract our 3 first because we cannot divide all those numbers by 4. So 4 times the radical of 2, or x plus 2, equals 16. Now this looks like letter A, where you can actually divide both sides by 4 and get a whole number. And 16 divided by 4 is 4. Square both sides, you get x plus 2 equals 16. Looks like you're subtracting 2, and your answer is x equals 14. All right, now I do have some more difficult problems which involve having radicals on both sides of the equation. So if you have a problem like this where you have no extra numbers, you still have to get rid of the radical. So in this case, it's actually not too difficult, is we just have to square both sides. And if we square both sides, the radical is disappearing. Nothing underneath changes. Again, radical disappearing. But the only thing is you just have x's on both sides, which is no different than a normal equation. So solve for x. So I'm going to subtract x. I get x minus 1 equals 4. Add 1. Looks like x equals 5. And if you were to plug x equals 5 back into the problem, if you were to plug it right here and right here, you would get an equivalent equation. And I do have one more for you. So this one, again, radicals on both sides. You need to get rid of them. You have no extra numbers. So square both sides. So radicals go away. 4x minus 3 equals radicals go away. X plus 9. Again, solve for x. Could certainly do it a different way. 3x minus 3 equals 9. Add 3. 3x equals 12. Obviously, I shouldn't have to show you the last step. X equals 4. Okay? So again, now not all of these equaled whole numbers. That's not always the case, but this is how you solve them. So basically, get rid of the radical, and you're getting an x equals. And I believe your assignment is on big ideas. You have 10 problems. Good luck, and try to get them all to be 100%. And I will see you guys next time.